How are you, grade 10? I hope you are fine and you are safe at home. Today we're going to continue our lessons, and from lesson 8.6 we're going to start our fourth quarter. Okay? Today we're going to take chapter 8, lesson 8.6, vectors. Okay? And of course you will have lessons in every Sunday, Tuesday and Thursday. You are going to have new videos for the lessons till we finish the fourth quarter. Okay? Today's lesson is about vectors. Of course, the word vector is new for you. What is the meaning of the vector? The speed and direction of an object moves can be represented by a vector. So what is the vector? The vector is a quantity, okay, that has both length and direction. Length and direction. So if I told you AB is a vector, so I must have two things: its length and its direction. Okay, to identify any vector, I must have two things I must know: the length and the direction. The length of the direction. You can think of a vector as a directed line segment. Okay, directed line segment. The vector below may be named AB or V vector. But take care of this. AB not equal BA. Okay, AB not equal BA, because they are not in the same direction. Okay, so the vector I can identify it by the length and the direction. A vector can be named using component form. Component form. What is the component form? Component form, and take care, this is the new way of the bracket here. Okay, you can write it as like this: X and Y. Okay, this kind of bracket means it's a vector. It's component of a vector. Okay, of a vector, list the horizontal and vertical change. So what is the X? It's the horizontal change. And what is the Y? It's the vertical change. Again, I can name the vector. I can also name component form for the vector. Here, X and Y. What's X and what's Y? X is the horizontal change and Y is the vertical change. Look here, if I have a vector CD, look here, if I have vector CD, this point C is my initial point. Initial means the point at which I start from. Initial means the point which I started from, okay? And what about D? D is my terminal point. Terminal point, the point which is I stopped at, okay? So, starting from initial point to the terminal point, CD is a vector, How can I get the component of CD? We're going to count the change in the x-axis here. This is the X. And this is the Y. Okay, what is the change in the X? The change in the X equals 2. And what is the change in the Y? The change in the Y equals 3. So I can write the components of the vector CD as 2 and 3. Okay? 2 and 3. Very good. So again, what is the vector? A vector here is a line segment, but I must identify it by both length and direction. Length and direction. And I can write it starting from initial point to the terminal point. Okay? And I can write it into component form. How? X and Y. What's X? X is the horizontal change and what's y? It's the vertical change. Okay, so I can say that the component form of CD is 2 and 3. Okay, let's continue. Here we have example. Write vectors in component form. Very nice question. Okay, let's see here how we're going to do it. I'm going to get down here to get my x, and here this is my x. Let's count. 1, 2, 3, 4. So it's 4 units in the x. What about y? What about y? Let's count. 1, 2, 3. It's equal 3. So this is the component of the vector EF. But take care of this. In the x we went where to the A, to the right, so it's positive. To the right it's positive. So it's positive 4, that's right. What about the y? What about the y? The y it's what? From E to F. From E to F I'm getting down. I'm getting down. So from E to F it's not only 3, it's negative 3. Negative 3. Why? Because I'm getting down, so it's what? Negative. So it's negative. Again, EF, the horizontal change for E to F is 4. And the vertical change from E to F is negative 3. Why negative 3? We said because we're going down. The direction is so important for the vectors. Okay? So the component form of EF is 4 and negative 3. Okay? Very good. PQ with P is 7 and negative 5. Here he give you the points. He give you the point B and the point Q. Okay? With order pair. With this is a order pair. How we can get the component form of this vector? We're going to say, do you remember with me? What we said here? We said that the x is what? Change in the horizontal. Change. Okay? Horizontal change. And what the y? Vertical change. So, we're going to make the horizontal change. 4 minus 7. 4 minus 7. Because we're going to make minus from the ending point. Again, we're going to, from ending point minus the initial, or terminal point minus the initial. So you have terminal minus initial. Okay, again, terminal point minus initial point. So 4 minus 7, it will be negative 3. And 3 minus negative 5 minus negative, it will be positive. So 3 plus 5 is 8. Okay? Again, if he give me the vector by drawing like this, I'm going to just count the squares. Okay? And see the direction. If I'm going to the right, so it's positive. If I'm going to the left, so it will be what? Negative. And for the y, if I'm going up, it will be positive. If I'm going down, it will be negative. Going means the direction I'm going to take for the vector. The vector here, E to F, so I'm going down. But what about if he give me the points in the vector, on the vector? What I'm going to do? I'm going to get the change in the x and in the y, the change in the horizontal and the change in the vertical. Okay, starting from where? Starting from the terminal point. So terminal minus initial, terminal minus initial. Very good. Now we're going to take another new definition, the magnitude. What's the meaning of the magnitude of the vector? It is the length. magnitude of the vector is the length. We said here in this vector, this is the component of the vector. Okay, but what about its length? What is the length of PQ? What is the length of the PQ? The length here is the magnitude. Okay, so the magnitude is the length. The magnitude of the vector is written as, you're going to write two lines and inside them the vector. When a vector is used to represent speed in a given direction, the magnitude of the vector equals the speed. Let's see this example. Finding the magnitude of a vector, draw the vector for a negative 2. To draw this vector, we're going to make x and y, and of course take your initial point. Take your initial point here. Initial point is the origin. Take your initial point is the origin, okay? And put a point for a negative 2, then draw arrow like this. So this arrow from the origin to the point for a negative 2 is the vector. This is the initial point, the origin, and the terminal point is the order pair of these numbers. Order pair, okay? How to get the magnitude? We're going to get the magnitude by the distance formula. If you remember the distance formula, it tells you what? x2 minus x1 square root. Square root. x2 minus x1. Sorry, I write it. Wait. x2 minus x1 all power 2 plus what? y2 minus y1 all power 2. Okay, do you remember the distance formula? This is the distance formula. Okay, of course I'm taking this, so the distance or the magnitude, I'm going to use this sign. Magnitude of the vector is equal square root of 4 minus 0 and negative 2 minus 0. So it will be square root of 20, so it's approximately equal 4.5. Okay, so what's the magnitude? Magnitude is the length of the vector. How can I get the magnitude of the vector? I'm going to get it by using distance formula. What is the distance formula? The square root of x2 minus x1 power 2 plus y2 minus y1 power 2. And of course, to draw the vector, I'm going to take the initial point is the origin, and the terminal point is the order pair, which is the 2 points he gave you. Okay? The direction of a vector, what is the direction? Now we took the distance, the length. And we said that I will identify any vector by its length and direction. We took the length now, and its name is magnitude. What about the direction? How to get the direction? The direction of a vector is the angle. The angle. Again, the direction of the vector is the angle that it makes with the horizontal line. So I must draw a horizontal line and see what is the angle between the vector and the horizontal line. Okay, I must measure it, and take care, you must measure this angle measured counterclockwise or anti-clockwise in this direction, anti-clockwise. Okay, because of course this direction is what? Clockwise. This clockwise, and this is counterclockwise or anti-clockwise. Okay, from the positive x-axis, the direction of AB is 60, because the angle between the positive x-axis and the vector is 60 degree. The direction of a vector can be also given as a bearing relation to the compass direction, اللي هي north, south, east, west. AB has a bearing of, look here, N means you are going to start from the north. Go from the north 30 degree, going to the east. So I'm going from north to east, making 30 degree. Okay? Very good. Finding the direction of a vector. When the velocity is given by the vector 2 and 5, draw the vector on the coordinate plane. What about drawing the vector on the coordinate plane? Of course, we are going to take the initial point is my origin, and the terminal point is the order pair of 2 and 5. Very good. Find the direction of the vector. After I'm drawing this vector, I'm going down here with a perpendicular line on the x-axis. So I made what ABC. It's what right angle triangle. Okay, right angle triangle. And of course, I can use trigonometric ratios here. To get the angle A, how to get the angle A? I have here its opposite and its adjacent. And if I have opposite and adjacent, I can use what? Which trigonometric ratio? Remember with me the trigonometric ratio, which opposite and adjacent? It's the tan. Very good. So the tan equals what? Opposite over adjacent. Opposite over adjacent. Okay? So I'm going to take tan A equal 5 over 2. If I want to get the angle, I'm going to get tan negative 1 or shift tan by your calculator. You can use shift tan by the calculator. Shift tan 5 over 2, it will give you approximately 68. Nice. Okay, for now, we're going to continue this lesson next session. I hope you understand it. Please study this part that we took, and we're going to continue this lesson next video, Thursday. Thank you very much. Here with you, Ms. Randa Wahid. I hope you are fine. See you later.